How about we finish this lesson? This is page 78 in the exercise book, and this is the last page of the 5.1 lesson. Number 19. Consider the following graphs. Well, they were nice to us on this one. They gave us the unit rates right here. If you want to write them as actual rates, you would say that the unit rate is 20 to 1. We could also say that the slope is 20. On this one, the unit rate is 10 to 1, rise over run, and the slope is 10. Which statement is true? The unit rate in graph B is 10 greater than the unit rate in graph A. So this is saying that 10 is 10 greater than 20. Is that true? No. The unit rate in graph A is 10 greater than the unit rate in graph B. Well, A is 20, is 10 greater than 10. That's true. The unit rate in graph B is 20 greater than the unit rate in graph A. Is that true? 10 is 40? No. The unit rate in graph A, that's 20, is 20 greater than the unit rate in graph B. 20 equals 30? No. The unit rates in graph A and graph B are equal. 10 is 20. Sorry, 20 is 10. Let me put it in the right order. I'm just making up stuff. Graph A is 20, graph B is 10. Are those the same? No. The true one is B. Number 20. Consider the table and the graph below, which show the cost in dollars Y of purchasing X printer cartridges at 2 different stores. So I go to the stores, either one of them, and I make a decision. What is my decision? The number of cartridges. That's independent. That's the decision that I make. And depending on that decision, this decision is made for me, the cost of the cartridges. So, neither of them show me a unit rate, so I'm going to find a unit rate. This one is 4 cartridges for $50. So let's break that down to 1 cartridge and see what we come up with. So you have $50 for 4 cartridges. How much for 1 cartridge? So 50 times 1 is 50, and 50 divided by 4 is $12.50. So the equation for this particular store, the cost is $12.50 times the number of cartridges. So I figured out an equation for that one. Over here, again, they do not show me a unit rate, but I can find it just by looking at the graph. I go over 1 and up 1, and there's a dot. We just need to calculate what that dot is. I know it's one cartridge. Wait a minute. No, I don't. Do you see the problem? This is not scaled. I didn't pay attention to my scale. This jumps from 0 to 3. So I cannot just eyeball the graph on this one. Dad burn it. But we can do what we just did in the other one. We can say that it's $35 for 3 cartridges. So let's break that down to just one. So 35 times 1 is 35 divided by 3 is $11.67 if you round it. So the graph here would be y equals 1167x. I just about made a serious mistake there. I was just assuming that that's a 1, but it isn't. It's a 1.5. But anyway, I have the unit rates and I have the equation that I need. So let's see what the question says. What is the approximate, so they realized that I had to round, the approximate difference, that means subtract, in the prices of purchasing one printer cartridge? I don't have to do much here. I know at store A, it's $12.50 for one. At store B, it's $11.67 rounded. I don't have a calculator handy, so let me just do this. 10 minus 7 is 3, 14 minus 6 is 8, and that's a 0. So about 83 cents would be my estimate, and I would go with option A. That's a very practical question. Most stores, in fact, it may be a law, that they have to put the unit rate on the price tag. So you have to be able to find that unit rate. I know at the grocery store it used to be on everything. I haven't looked in a while. Because honestly, I do this in my head. Now that I've learned to use these things, I actually use them in real life. Okay, number 21. Consider the following graph of a unit rate. So they're saying that if you go over 1 and up 1, there's your unit rate. So I would really like to know what that really is, and it's 125. So over 1 up to 25, the unit rate is 25 to 1. Which description of a unit rate could not be represented by this graph? Total sales that cost $25 each, dresses that cost $25. So this would be the cost equals $25 times the number of dresses. I biked 100 miles in 4 hours. So the total distance biked would be 125 times 4. That's true. So let me set it up this way. Miles equals 25 times hours. So that would fit. The total cost for a box of 25 paper clips at $1 each. So that would be $1 times the number of clips. The total miles you can travel when the speed limit is 25 miles an hour. So miles would be 25 times hours. Or the total number of compasses shipped in boxes that contain 25 compasses. So this would be the total number equals 25 per box. All right. So which one doesn't fit? Which is the one that doesn't fit with this graph? It is C. And I'm going to have to think about how to explain this to you. I think I'm going to do it with a unit rate. All of these, how do I do this without, I know what I want to say, but I don't know how to say it without getting really confusing. It's my formula that's mixed up. Let's rethink this. I hate these kinds of questions because I know in my gut that it's C, but how do I best explain it to you? Cost is $1 times the number of paper clips. Let's go at it this way. So this would be cost equals $1 times 25 clips. Does that even make sense? $25 for a box of paper clips, for 25 paper clips, that doesn't make sense to me. That's where I'm saying in my gut, I know that that just cannot be. Here's the reason. The unit rate, and let me put it on a graph. Let's see if we can make this make sense. So on a graph, you are looking at the cost, which we're saying is $25 of paper clips in a box. So this would be the number of clips. What would the price per clip be? Let's go at it that way. If you have dollars per clip, in my formula, it's saying that it's going to cost you $1 for every paper clip. So the unit rate on this one is 1/25. The unit rate on this one is 25/1, $25 for one dress. This one would be 25 miles for 1 hour. This one would be 25 miles for 1 hour. And this one would be 25 compasses in a box. So this C has the wrong unit rate. This is saying that each paper clip costs $1. And that doesn't make sense in real life. It also doesn't make sense mathematically. It's not the right relationship between those two. I wish I could say don't worry about that question, but I actually think it's a pretty good question. I'm just not sure I did a very good job explaining it. Okay, finally, consider the table of values for a linear relationship.